Hey, good afternoon, everyone. I am Dan Barker. I am the Chief Architect of RSA Archer, which is a Dell Technologies company. Who here has experience with data science or is a data scientist? All right, so a few of you. This will be fairly basic, so hopefully you will learn something, but I'm trying to introduce everyone to some of these ideas and the tools that you might be able to use to go learn on your own. Also, I think that thing is amazing, and I'm probably more entertained by this than I should be. I don't know. Well, it's not perfect, right? So this is AI. This is using a lot of the technologies that I'll be talking about to try to interpret whatever it is I'm saying, and then use that to represent the language in this text format. And it's likely getting so when it looks up this pattern of whatever the wave format is that I say a certain word, it will get several results back, and then it tries to choose the right one. A lot of times it will get it wrong, but a lot of these systems now use the full context of the sentence, so it's getting more and more accurate. There is still a lot of error, but we also have a high error in human interpretation of language as well. As we probably all know, regularly interacting with other humans. I also help organize DevOpsDays Kansas City, which is now up there, which is awesome. And we will probably get one of these because I'm entertained. I'm also, aside from being a chief architect, I'm also getting my degree in data science from the University of Illinois. Doing most of that online through Coursera. There's a similar program for Georgia Tech for anybody who wants to do that more locally. So why even bother with AI, other than it makes that awesome thing over there? I will probably reference that thing more often than I should. Yeah, it's awesome. Well, when I came in and saw it, I was like, oh, this is amazing. This is exactly what I'm talking about in practice. We have a lot of information already that we can leverage. And so one of the pieces of AI is that, or building any new feature, is that you have to get a lot of different things to be able to build this new feature. Well, with AI, we usually have a lot of those things already. It's a matter of formatting that in a way that we can use that in data science. So we already have usually user data in your systems. So you have what people have clicked on, what people have bought. Maybe you have a system that has content that people are putting into your system, and you can use that to learn more about those individuals or learn more about what they're writing. Medium.com would probably be one of those that can use a lot of that textual data to learn more about what people are thinking about in society. We also have system data. So if anyone here works on the back end side, that's kind of where I got started in data science. Was more around the CPU, memory, disk space type metrics, and applying data science methodologies to that to better manage those systems. There's also a ton of free data. So there are thousands of free data sets out there that you can go and use and explore, and you can have those be something that you just learn on, and then you can translate that learning into your own data set. And some of those data sets will be applicable enough to what you do in your day-to-day job that those might be things you could actually use at your company. There are restrictions to that free aspect of it. So please don't just use them just because they're on the internet. A lot of researchers have spent a lot of time creating those data sets, and some of them require open sourcing the other stuff that you use it with. So be careful around licensing, like with any free type software. So what are we trying to solve with AI? A big one is fraud. So I was in the insurance industry for a little bit on the kind of regulatory side, and fraud was a big issue. Fraud is a challenging one to solve because if you look at, say, insurance transactions, insurance claims, almost all of them will be real. There's very little fraud actually in those transactions. So you could write an algorithm that would get about 100% accuracy just simply by classifying all of them as not fraud. Yeah.
My boss was like, let's try to find fraud. Like,
It's
99% accuracy.
but still failing at it. and I'm putting a bunch of things into fraud that aren't really fraud. So it's really hard to classify fraud accurately. There are methods of doing that, but that's probably kind of on the bleeding edge of classifying these incredibly low occurrence events. There's also disk space. So this is really the first time I was introduced to data science at any level. And it's a simple linear regression. Linear regressions are very commonly used in data science to get results. There are logistical regressions, lots of other types of regressions that are very effective. For the disk space piece, I was working for a company that would send you a notification at 80% disk utilization, and then at 90% they would auto grow it. So we all just waited till it hit 90%. There's really no reason to do anything else. And I was on a team that was the data science team, and we pulled down 10 terabytes every night. And this was a couple of terabytes of disk space that they were worried about. And so I told them, it doesn't matter. If this actually gets filled up, or so we would delete 10 terabytes every night. So if we forgot to delete it, we're not going to make our deadlines. But I had a separate tool called Prometheus, which has built in a lot of these data science concepts. And that system had a linear regression in it that could tell me to the day when I would be running out based off of previous usage. So it looked back all of my other usage, and it bucketed that up, and they could tell me how much I would consume, and I could program it in so that it could tell me what day it would finally expire. I also had an alert system set up so that if ever it was going to fill up within a month, it would notify me of that. So if overnight, so it was updating every 5 minutes. Every 5 minutes it would check, is this going to fill up within a month? And then it would notify me. We never actually had that happen. Our system never failed. But we knew that if we failed to delete that 10 terabytes, we would definitely overflow, and it would notify me in time so that I could go in and manually delete everything, or stop the process so that we could recover. But that was a very effective use of a very simple piece of data science and AI. And the biggest part of this is that we're trying to find patterns in our data, and then use those patterns to either describe and better understand the emergent properties of our data, or we're trying to predict what a new data point might be, or how that might be interpreted by our system. And there is a bunch of links here for free data and the associated research. There will be another slide at the end that will list these again. So Google actually has a completely dedicated data search system that you can just type in whatever you want, just like Google, and it will give you all the different data sets. And they are there where you can, usually there's a link where you can download them. Kaggle is another great tool. They actually have competitions. So if you're just learning, you can go there, or if you're experienced, you can still go there and learn a lot from their different competitions. And they also have a ton of data sets hosted on that website. Scholar.google.com is for searching scholarly articles. They're not all free. If you go and take some classes, then you can get access to those generally. But Archive is the source of all free research. Most data science researchers will try to publish there as quickly as possible before they publish to a peer-reviewed journal, because they kind of want to claim dibs on the research. And once you post there, you have prior art, and you're golden. You've established your superiority, I guess, over all other data scientists. But you can go there and you can see like the latest research, the absolute latest stuff. Some more free stuff: Jupyter Notebooks and Google Colab. So Jupyter Notebooks are run locally, and they use your local resources. I find it to be very complex to manage all the different versions of Python, and there's a tool called Anaconda, and there's a lot of other things that you can manage with this, especially when I have only a work laptop or something. That becomes even harder because they have a lot of restrictions, and so you just end up stumbling over and over again. But Jupyter Notebook also has a server component called Jupyter Hub, and that's essentially what Google Colab is a system of Jupyter Hub that you can go in and create a Jupyter notebook the same way. And the Jupyter Hub, some companies will actually run that internally as well. So if you want to do this internally, you could run a Jupyter Hub and have this similar type of experience as Google Colab. Google Colab uses cloud resources, so you don't even need your own computer. You just need something to access it. I've actually done this on my phone before for school. It's harder, so don't do that. But in a pinch, if you only have a phone, then you can certainly use Google Colab on your phone. Google Colab also has GPUs and TPUs. So I didn't have a computer that had GPUs, and most laptops have very minimalist GPUs. And so I use this for a lot of my homework. And I generally use this if I'm using something like PyTorch. TPUs are tensor processing units. Tensors are a confusing mess. I'll briefly mention them later, but it is not something I would start out with. But it's great that they're available because you wouldn't normally get that on a laptop. Google Colab can also use a local runtime of Jupyter. So if you do have a local runtime, you could always hook it up to that. So we've learned a little bit about some of the free stuff, but let's talk more about what AI really is. So everybody knows digital, or they've heard digital transformation. Your company is going digital. We want everybody to be digital or something. I feel like digital has no real meaning because it means something different to everyone. I find that AI is more well-defined, but it seems to include everything that relates to any kind of learning or intelligence in computer systems. So we're going to focus that a little bit more on natural language processing, which is what that's doing right now, machine learning, and deep learning. There's a couple of other ones like vision and robotics. Those are much more tightly coupled with the actual physical layer than the software layer at this point. Vision has made more separations there than robotics, obviously. So natural language processing, normally referred to as NLP. I believe if you Google NLP, something else comes up. There's some other neurolinguistics or something like that. Yeah, so that's not what we're talking about here. So natural language understanding is being able to take some textual data or using speech recognition to take my speech and turn that into some comprehension of what I'm saying. We can use sentiment analysis. So you see this a lot with Twitter posts and other types of social media analyses where you want to understand more about the general nature of someone's sentiment about a company or about a particular topic. So you see that applied a lot, and that's kind of within the bounds of natural language understanding. And then you have natural language generation. So people have heard that whole articles are being created by AI. Natural language generation is more of a newer phenomenon. It's still, I think it's still in a burgeoning state where it's not fully established. A lot of that stuff requires human templating and creating some sort of scaffolding before you can inject the content of say, a new IPO or a baseball score or something else. And there's a whole bunch of other NLP type things. You can go and look through all the different things, but we'll stay focused on natural language understanding for this. So there's a lot of different NLP tools. I wrote an article going through all of these as well as some Java ones. I'm only going to cover the Python and Node because I find those to be a little bit easier to work with. So in Python, we have Natural Language Toolkit. This is pretty much the de facto standard for data scientists that want to work with natural languages. It is very hard to consume. The documentation is quite dense. So TextBlob was created as kind of an abstraction around NLTK that helps you consume it a little bit more easily and be a little bit more effective. So we'll look at this one a little bit more. SpaCy is probably the primary alternative to NLTK. SpaCy is a little bit easier to use, probably more on par with TextBlob. But another tool called Texacy was created to do some pre and post processing around some of the spaCy primitives. And there's also PyTorch NLP, probably not great to start with. That was a confusing mess for me with the tensors and having to understand what tensors were and interacting with tensors differently. There's also a bunch of node tools. These are pretty great if you're working in Node.js. A little bit harder to work with when you're learning because Jupyter and those tools don't natively support Node.js. There are ways of doing that and using Node in those tools, but I think it would be a harder lift when you're just learning. These tools are all really good. They are all very simple. They are simpler than the Python tools, but they're probably more effective for your visual type use cases. So we're just starting. We have text blob and text-to-see, and oops. We're gonna go. So this is Google Colab. You can see I'm connected. I didn't check this earlier, so I'm glad it's connected. So here's my RAM and disk. It shows 13 gigs of RAM, which is pretty good, and about 50 gigs of disk space. And if we go over here to runtime, we can actually hit change runtime, and we can see that we can have Python 3 or Python 2. And we can select GPU or TPU. If you change this now, it would wipe out like everything. So these stay up for 12 hours. And so you can have everything saved there for 12 hours. It's like a container running in Google Cloud somewhere. And you can come back to it and all the state is still there. So I ran this earlier because, conference stuff. And we'll see if it runs again. So you have to install text-to-see because it doesn't come in the base image. All right, that's all there. Perfect. And then you import it into the context, and we're going to create a little bit of text here. Is that better? Yeah. All right. So we put in some text. We import text-to-see. And then we want to pre-process the text. So a lot of times you'll have different cases. You'll have punctuation. You need to clean up all that and get rid of that. That doesn't matter in the grand scheme of learning in this system and analyzing a corpus. You want to lowercase it because you don't want to have a capital language and a lowercase language not end up being the same word. And there's a lot of other things you can do to this. As far as pre-processing it, there's stemming, lemmatization. There's a lot of different things that you don't necessarily need to worry about if you just apply some simple pre-processing that's built in. It's great to learn about, but it's something I would dig in after I kind of experiment a little bit. So that lowercase everything, and then if we run this, this shows that it's clearly dependent on spacey. We're creating a spacey document. And then here we're breaking it up into n-grams. So a common tool is to break up a longer set of text into smaller pieces of text. And in this case, we use groups of 3. You can use groups of 1, 2, whatever number. And that will reveal different things within your document. So here we have natural language processing. Notice that I did not process this I did not process it again before I put it in there. So we have natural language processing with the capitalization. And if we come down here, run this again, and this is all running, and then the output will stay there. Here are the key terms, and there's also a score here that you can learn about later, but it shows that language, when we're talking about natural language, is the most common word. And it even has readability information, or like a grade level. So you can do really quick analysis of, what is the grade level of this article or this set of articles. Right now we just have a very simple set of text there. But there are ways to load in entire data sets. So here we have all of the Supreme Court decisions from the modern era. And this will download it, and these all exist in text-to-see, so you don't have to go and find them somewhere else. All of these data sets exist in here, and a lot of these tools have that, where you can just grab the data set from within the tool, which is really helpful because you don't have to go dig through Kaggle or some other data search system. And this was already downloaded, so it didn't take that long, but it was pretty fast when I did it earlier. This takes a lot longer. We're only loading 25 records, and we're creating a corpus abstraction. And so we'll just talk about it here. So there were 25 documents, which is what we would expect since we put a limit of 25. There were 6,063 sentences and that many words. Tokens is what you generally refer to as words, or something that would be more the format of a word. It could be an n-gram. And so we can do, now that we have all that data, we could do a whole bunch of other processing. We could do sentiment analysis on it. We could try to learn what types of things make it to the Supreme Court more often. We could also apply some of the data that's within so there is some labeling or some fields that were entered into this data set. And we could use that to try to understand how the court generally rules, or maybe even try to predict the future of how a court would rule on a particular case. So that was Texasy. We'll switch over to TextBlob. So TextBlob relies on NLTK. And then if you don't download these, it will tell you TextBlob is very nice to you, and it will tell you exactly what to put in there. So you just copy and paste and put it right there. And here you have tagging. So tagging, this is a part of speech tagging, or part of sentence tagging. So you have your nouns and verbs and things like that here. And that helps understand kind of what it is, or what the text means. And you also have these noun phrases. So these noun phrases are kind of taken from some of that information. But you have a statistical revolution, late 1980s. However, it isn't always right, and you have something that probably, this is not someone's last name. It's probably not a General Robust. But that's what it thought it was. And these are pre-trained, so you don't have to train these. Most of these systems that are a little bit easier to use don't require tons of hours of training. You can also translate. So you can translate that into Spanish really quickly. I don't know. I don't speak Spanish, so I don't have any idea if it's right. But it's probably as accurate as Google's translate system. Here we'll have a REFACTR Tech is the best conference ever, and everyone should attend. Here we're doing some sentiment analysis. It's funny because it says that I'm not being very subjective. I'm being very objective. But it is showing that it's very positive. And then if we do something negative here, leaving REFACTR Tech is the worst. No one should have to leave. And that shows that I am being very subjective, and it's a very negative thing. It's got the -1 there. So those are just some of the pieces that you can do very quickly. A lot of this was in the tutorials or the quick starts, or it was something I just wrote really fast last night as I was looking through the API documentation. Yeah, there's not actually 40 minutes left. It's a lie. Okay, so machine learning. So we've talked about, let me get back over here. We've talked about natural language processing, and now we'll move on to machine learning. I didn't write any of the code for machine learning because it often requires training, and most of the work I've done is either writing my own algorithm or training some sort of a model, and that can take more on the order of tens of minutes to tens of hours. So it takes a little bit more time. So I didn't do any demos on this one. Is it not? Sorry. So what is machine learning? Machine learning is kind of broken up into a couple of different models. One is supervised learning. So supervised learning is focused on predicting the future or predicting what the next data set, what kind of attributes the next data point would have. It's usually using labeled data. It's usually applied by other people, although there are ways of automating this. There are also ways of discovering this information without humans having to intervene. So, for example, you might have like house prices that you want to have in this model, and that's the label that you want to apply, and you want to have some different classes of these house prices. But some house prices that you could get automatically are the price of the lot. And so that doesn't actually represent the cost of the house, and it's not great to have bad data in your data set. So you probably need someone to go through and make sure that the labels are valid. But then again, there is some human error in all of this anyway, so even a human analyzing this is not going to be completely accurate. So a lot of times we are okay with some error in our labeled data set. So some primary models of the algorithms are regressions and classification algorithms, and here are some of them. There are a lot of different algorithms. Linear regression is what we talked about earlier with the disk space. Nearest neighbor, like K nearest neighbor, is a way of, let's say we had 5 different classes of house prices, then you would choose the K would be 5, and you would find out the boundaries of those 5 classes by training your data set against some labeled data set, and then you would take an unlabeled data set and try to classify those new data points and determine which class they would be most likely to fit in based on wherever they lie. So when they get plotted in this is where it gets a little more complicated. So these are multi-dimensional data spaces that could be more than 3 dimensions. But when you plot that point, this algorithm can find the distance to the next point and say that it is now associated with the class that point is associated with. Naive Bayes is probably the most common one I use. I just use it all the time. A lot of people do. It's a great go-to. Unsupervised learning is the other type, and it helps more with some of the emergent properties of your data set and being more descriptive. There's no labeled data in that model, and it uses things like clustering and association algorithms. So that would be like a k-means, and I've also used agglomerative hierarchical clustering. You don't need to know what any of those words mean generally. They're often just pre-trained algorithms inside of one of these systems. K-means is something where you can kind of select the K. That would define how many clusters you think might exist in your data set. And adjusting that K, that number of clusters, can help you understand the data better as well. So you might say that there's 3, and then you plot all of the data points, and you find there's a lot of different ways of plotting this information to find the right K. But a lot of times you can do it just through some random analysis and then looking at what the plots look like on the other side. Usually patterns will be pretty evident. So
the new that Google AutoML, would that be supervised or unsupervised?
The which thing?
The AutoML, Auto Machine Learning.
AutoML. What is that?
They launched at Google I/O.
I have no idea. I don't know. Well, it might be both. I mean, it's probably just a tool set like some of these others where it looks at the data. Well, that would probably be unsupervised. Oh, it could be neural nets. We'll talk about that in a little bit. We'll cover that quickly because that's a more advanced topic and it requires some additional resources usually. So what kind of ML tools are there? So there's NumPy. Has anybody here heard of NumPy? It's like the most common Python thing for numbers. Everything else is pretty much built on this. So I'm glad whoever made that. Who here has heard of Pandas? Yes. So that's the other tool that's built on top of NumPy. It provides a lot of other abstractions. One of those is called a data frame, which is kind of a database logically to some extent. It essentially has all these different types of tables. You also have matplotlib, which is kind of unrelated to the other two, but it allows you to plot that type of information very, very easily. Gives you a lot of nice graphs. There are other plotting libraries, but all 3 of these are used to build SciPy. And SciPy gives you some of these. So the first three don't really have a lot of AI, ML type tools. They are really the building blocks for the other pieces, but you need to understand them because you'll be Googling a lot on those, especially when you try to get NumPy and Pandas and the next one that I'm going to show you in a minute all working together. So SciPy is a great tool to use, but probably the de facto standard for ML in Python at least is sklearn, scikit-learn. That does not, it's built on like NumPy and some of the other tools, but it does not integrate with Pandas data frames, which is incredibly frustrating because you have to convert them over to NumPy objects to be able to use, or there's a few other ways of integrating that. But you'll find that using Pandas and the abstractions it offers is usually worth the effort of converting them. You'll just be Googling a lot of how to convert this Pandas thing to this NumPy or this scikit-learn thing. And you'll learn about NumPy arrays and you'll be using them all over the place. So those are kind of the core tools for machine learning that I use on a regular basis. I also use PyTorch. We mentioned PyTorch earlier with NLP. PyTorch uses tensors. So if you get confused with NumPy and Pandas like I do, you'll be even more confused when you have to use tensors and the fact that they don't seem to work well with anything else. So I would say that after you get comfortable with the other ones, maybe jump into PyTorch. That is a GPU oriented, or at least my usage of it is primarily GPU oriented, and using GPUs to do faster processing of these data science type things. It is definitely harder to interact with tensors when you're just starting out though. Okay, so deep learning. So deep learning is actually a part of machine learning. I usually treat it a little bit differently, but it's basically a subfield of machine learning. It is hierarchical feature learning. Oh, did that thing turn off?
It seems like it timed out, but I'll take it.
When did it turn off? I would stop watching it. So hierarchical feature learning is kind of how our brains learn. Previously I was a psych major a long time ago, and then I found out that doesn't make any money at all. But it was fascinating, and I encourage everyone to go learn more about the neural side of at least psychology. The way our brains are built is the way we try to build a lot of these deep learning systems with neural nets. And we interpret the world, or our brains interpret the world. Each neuron might interpret a horizontal line, and then the next set might interpret vertical lines. And then several layers down, you might say, oh, well, that's, this object I'm looking at is an automobile, or the cells would. And then the next layer down, the cells might say, oh, well, this is a truck. And then the next layer is, oh, this is a Ford. Oh, this is a Ford F-150. And then the next layer may add even more information around, oh, this is the best-selling car, in the US or something, or other facts about it. And that's hierarchical feature learning. And that is one of the reasons that we don't understand neural nets as well as a lot of these other areas, because these learn on their own. So we don't define like, hey, this layer is going to learn this type of thing. Like this is going to have the horizontal lines. You run a bunch of training data through it, and it figures out somehow through optimizations how it's going to interpret at each layer. What features are going to come out at each layer. So that's you have deep neural nets, you have convolutional neural networks. A lot of these are built into the libraries, and these are not something I would start out with, but there are the features are built in, but there's a lot to how you layer them and how you normalize them in between the layers and how you do other processing to them in the middle of that. And there's also generative adversarial networks. So if you're in my Google News feed, this is up constantly recently, because you have all of these networks. So what you do in generative adversarial networks is you have competing networks that are trying to build a better system, essentially. They're using these a lot to build new systems, and you're seeing a lot of these things creating pictures and photos, and you're seeing these human faces that those people don't exist, which is insane. But now you have these photorealistic pictures of people that aren't real. You also have videos being created from like the Mona Lisa, and a lot of these are because of these deep neural nets. And again, I should say we don't really understand what's happening in those layers. We're doing more research to try and understand how they learn and what's happening inside of the system. But we can't predict. And so every single time I run one of these, it changes. The outcome is non-deterministic. So there are a lot of different deep learning tools. One of those is TensorFlow. That was created by Google. There's a lot of good tools in the Google Cloud for that. That may be what the AutoML stuff is using as well. You can build a lot of neural nets with that. There's PyTorch. There's Keras. So Keras is a really common one. That's a much easier tool to use. And TensorFlow is not simple. But Keras is much easier than most of the ones I've interacted with so far. There's Caffe, Microsoft Cognitive Toolkit. That's a pretty good one as well. It's pretty easy to work with. MXNet and Chainer. So we'll talk a little bit about bias in data sets. Right? So I was the chief architect of the National Association of Insurance Commissioners. And I went and spoke at a insurance CIO, CAO leadership summit, and I had this slide in it. So I was a little hesitant to put a meme in a slideshow to a bunch of insurance execs. Maybe it wasn't a good decision, I don't know. But we did talk about this, and it's something that they all recognize that there is bias in these data sets, and I know that there are articles about people not caring. It's just an incredibly hard thing to deal with because it's hard to know if there's bias. So we have cognitive biases. Everyone knows what cognitive biases are. There's like a whole bunch of different ones, and we all suffer from them. The best thing we can do is try to be aware of our biases. And these have been studied for many years, and we still can't avoid them. So we know that these cognitive biases exist. What in the heck? So Mac is not being successful right now. So we still can't avoid these. We know they exist, and a lot of times we can see them happening, and we still can't stop them from happening. So algorithmic biases are barely understood. We really don't know what we don't know, and they were first covered in 1976, and not really again for 30 years. So we have very little knowledge around how an algorithm could be biased or how the data set could be biased. And only recently did Cathy O'Neill write Weapons of Math Destruction, which I urge anyone trying to get into this field or using this, I suggest you go read that book. It's an excellent book, and it's probably the most modern interpretation of algorithmic biases and how to try to avoid them. So we don't understand these cognitive biases. This is kind of a complex systems theory applied to cognitive bias. We don't accurately attribute the success and failure, so it's hard to attribute why a particular algorithm became biased, and it's hard to say that it was our algorithm or that it was the way we manipulated the data set. It's also very hard to look at the data set objectively and not put your own biases into it. And with a lot of these data sets, hundreds of people are involved in creating the data, and they're all putting their, apologize, I have no idea why it turned off or turned back on. I will turn that off. All right. There are hundreds of people putting this data into the system, and they all have their own biases. Now, hopefully a lot of that bias, if people are diverse enough, hopefully that bias washes out. But a lot of times there are similar types of people putting in certain types of data, or there are certain types of data that are being collected that are more likely to be collected. For example, a lot of psychology is based on college students. So not terribly accurate for a lot of the rest of the society. And that is all that produces that algorithmic bias. It is really hard to separate the outcome from the input. So we need to move forward, but we need to do it mindfully. And we need to think about the bias and how this could be biased. And if you get an outcome that you don't necessarily expect, it could be biased data, and you should analyze the data. And this is a lot of this is not just running all of these algorithms, but also using some of these visualization tools to help better understand and describe that data set. And these are all of the different resources. So KD Nuggets is a great aggregator of awesome data science content. I see it all the time. Coursera, so Andrew, I have no idea, NG, Wah? What, from Stanford? It's NG is his last name.
Yeah.
Okay. So he's awesome. He helped found Coursera, and he has probably the best machine learning course I've ever seen. It is very easy to understand, even if you don't have a data science background. I suggest you go there and check that out immediately. Towards Data Science pops up on my feed constantly. There's a ton of content there. Opensource.com, we're trying to get, so I'm a writer for opensource.com. If you want to write for opensource.com, we would love to have you write at opensource.com. Please reach out to me. I will be here after the talk as well. And I've started to write some more data science stuff. I've mostly been focused in DevOps, but I'm trying to write more on that. And then there's, I think all the rest of those we've covered. And then the Weapons of Math Destruction book is at the bottom. So feel free to take a picture. If you need to contact me, those are 2 different email addresses you can use. And what's that?
Where did you get that sub-level domain? The codes.
Oh, Google domains. They release code. I don't remember when they released codes, but I went and bought it immediately. I also have barker.app. So whoever is a veterinarian or there's a shoe company, they'll probably want it someday. It's the only one that I was able to get, and I bought it like immediately. All right, I'll leave that up, and I don't have time for questions, but I am here for the next couple of hours during this event, so please feel free to come up and ask me anything. And definitely write for opensource.com. It's not hard. I will help you. Thank you.